Let's put this all together and write some programs. We're going to start with a super simple program, which is just going to swap the contents of two registers. So we'll initialize those registers using the IR move queue instruction, immediate value into a register. So we're going to take the value face, put it in RAX. We'll take the value cafe, and we'll put it in RBX. You may recall that to swap two values, you need a temporary register. So we're going to use RCX for that. And so we say we're going to do register to register moves. So take RA, put it in our temp. That's the first instruction. Take RB, put that into RA, and then grab our temp value and put it back into RBX. This might be a little abstract. So what I want to do now is pull up the class simulator so that you can actually see what's happening in memory and in the processor when we execute a program like this. So if you look at the Canvas main page, you'll see that there's a link that says simulator. That will take you to a page where you then can open the simulator. You may need to add your CWL credentials, but eventually you will get to this lovely simulator. Now, what you'll see is that we have all the registers laid out, and then we also have some more detailed information that will become more relevant as the course goes on. So for now, I just want to focus on the contents of the registers. Let's pull up the swap program, which I have conveniently set up here. Okay, so here's our swap program that I just showed you. And now what you can do is you can actually run this one instruction at a time. So if I say run one cycle, we'll see that the value face is now in the register RAX. If I run another cycle, cafe is now in RBX. So I can click one cycle and see the values move around. So I copied what was in RAX and I put it into RCX. So now face is in both registers. One more instruction, I took what was in RBX, which is cafe, and I put that into RAX. And finally, I took that temporary value, I put it back into RBX, and now I've swapped the values of RAX and RBX. So this is a great way to debug your Y86 programs and also get a better sense for exactly what's happening when we execute these instructions. Now you'll notice this display over on the left. What's that? That shows you the actual contents of memory. So remember, every instruction has an encoding, and it's represented in a little endian representation. So this 3-0 represents the immediate to register move. The F0 says that the registers I'm using, RA is not used, so we have an F, and for RB, I'm using register 0. And then you'll see in little endian representation, the value that I'm putting in the register padded out to 8 bytes. So this whole piece is the first IR move queue instruction. This whole piece is the second IR move queue. And then you might remember that the register to register moves are each only 2 bytes. So there's the first, there's the second, and there's the third. And then our program ends with the halt instruction. Let's look at a slightly more complicated program. So this time I'm going to load a program that is going to also do a swap, but this time it's going to do the swap from 2 memory locations. So you should immediately think, like, how do I indicate where memory locations are? That's a great question. So you'll see at the bottom here that we have a couple of new, they look like maybe instructions, but they're not actually instructions. So things that begin with dot are called assembly directives, and they basically tell the assembler things about how to lay out data. So what POS says is, I would like this to be at address 100 hex. And what I would like to put there is actually some data. So the dot quad says, allocate a quad word, put the value face into that quad word, and similarly do the same here. Finally, the A colon and B colon are basically ways that we can give names to memory locations. So just like you name variables in higher level languages, you can name memory locations to make it easier to write code. And if you look in memory, you'll see that at address 100, just like we asked, we have cafe. I'm sorry, we have face. Caught myself reading the little endian notation. And then at address 108, we have cafe. So now if we look at this program, what we're going to do is we're going to load R11 with an immediate value, but where are we getting that value? We're using A, which was this variable name down here, as a constant, right? Because that constant is in fact the address of this memory location. And we happen to know that that address is hex 100. So let's actually execute the first instruction so we can see what happens. So I clicked reset, and now I'm going to say run one cycle. And what you'll see is in R11, we now have the value 100 hex. Now that I've set R11 to contain the address where my data lives, I can move the values that are in memory into registers. How do I do that? Well, I use my load instructions or my memory to register move. So what address do I want to use? Well, if I want to get the value A, I'm going to take the contents of R11, and I always have to add an offset to it because that's the addressing mode. And so in this case, the offset is 0. So I'm just saying whatever R11 contains, use that as an address, take the value that's stored at that address, in this case, face, and put it into RAX. So let's see if that worked. And sure enough, it did. So here's RAX, and it now contains face. This next instruction is just a little bit different. Now what we're saying is, okay, I don't want the value that's at the address pointed to by R11. I want the next one. Well, the next one is at an address 8 bytes bigger. So I want the offset to be 8. And so what that says is take 100, add 8 to it. Notice that that's this address. And now take the value there and put it in RBX. So if I execute another cycle, RBX now contains cafe. In the previous example, we then used a temporary value and moved things around. But I already have temporary values now. These registers are really temporary locations for this data that lives in memory. So now that I have those values in registers, I can just write the values back to memory. So what I'll do now is take the value that's in RAX, and I want to write it back into location B, which is 8 off of R11. So now I'm going to take the value that's in RAX, face, and it should change the contents of memory at 108. So let's try that. And if you'll notice, we took that value, and now in memory, both values are the same. And you're like, oh, did we lose the other value? And the answer is no, it's still in a register. So now when I run one more cycle, I can take that value that I put in RBX, and I can move it into memory at location A. And so sure enough, I have swapped the two values that I started with. These programs are all accessible. You can run them on your own, and you should take a few minutes to make sure that you really understand what's going on there. And we'll get more programs as we get more instructions.